Alright, so today we are going to work on lesson 3.4, which is graphing ratio relationships. Okay? Now, what this is, in lesson 3.1, we first learned, I'm going to make this zoomed in a little. In 3.1, we learned how to identify a ratio. Like, hey, I have a ratio of something 2 to 3. We learned how to write that. I have 2 boys for every 3 girls. We learned to write that ratio out. Thank you. So that's all we did like in lesson 1. We were learning to identify any ratio. In lesson 2, we went ahead and said, hey, 2 to 3 is represented in a tape diagram as 2 parts for every 3 parts. We learned to draw that. In lesson 3, we went ahead and we made a tape, a ratio table. And a ratio table was a way to show equivalent ratios. I have 2 to 3. That's the same as 4 to 6. It's the same thing as 12 to 18. And we'll just leave that. We made that ratio table. Today, we're going to continue to build. Do you guys see how everything's kind of flowing together and just continually building off each other? In order to do this ratio table, I could use a tape diagram, and the tape diagram comes from a ratio. Now, today, what we are going to learn is about graphing ratio relationships. Mainly, I'm going to say, here is a coordinate graph. Here's 0, and then we have so many tick marks as we go along. We'll label those. We'll practice that today. And we're going to say, hey, what's the relationship of this? And I'm going to learn to graph that point. What's this one? I'm going to graph it. What is this one? I'm going to graph it, and we're going to make a straight line out of it. That is what we will end up doing today. We're going to learn to use a ratio table to identify coordinate pairs and to graph it. And we're going to discuss why we care. Why do we graph it? Is it just because we found out we could do it and we're like, yay, more homework for kids? Okay, that's part of the reason. No, it's not. Yes, it is. I know. Hearts of coal. It's black. It's awful.
Hearts of diamond.
I go home and I laugh at how much you cry. It's great. Alright, so it makes me feel good about myself. It's like a little bit of warm Christmas cheer in my heart. Alright, so here we go. Exploration 2. Make sure you're on Exploration 2. We're not going to do number 1. We're not going to spend too much time on this. It says, work with a partner. Joseph, who's your partner? What, Joseph? Good, your whole table group. I know that's what you said. Good job. So, here's what you guys are going to do. In your table group, you're going to use this graph. I'm going to see if you can figure out what this graph is. Right here, if everyone would draw this table with me. $72.
Oh, yeah,
If you would make this table with me, what I'd like you to do is on Exploration 2, work with your table group, and can you guys identify what my ratios should be? So this is a ratio table. You're going to try and identify some equivalent ratios based off the graph. When you get done, it says, also talk as a group. What is this black line? What do these black lines represent? What are these gray lines representing? And then what is the dashed arrows down here? Okay? There's one down here too. Alright. So I'm going to pause. Go ahead. This is where I want to hear you talking. I won't yell at you for talking as long as it's about math. So go ahead, turn, work with your table group. So what do we got here? Who can tell me what is one of the ratios that would have fit with this table? Siri?
Can I just do any random one, or do I have to do it?
Let's do it in order.
Okay. The first one is 5 to 2.
5 to 2. You would have seen it right here. Alright. Good job, Siri. Caleb? We would have 10. 4. There you go, good buddy. Right there. And the last one. Which Joseph are you? Good looking one
No, he's
or
the smart one. This is the good look.
Smart one? Alright, smart Joseph. 15. Can't wait till like parents are watching my video and they're like, oh God, did you just call one of them smart, one of them good looking? So the other one's dumb, the other one's ugly? I'll be like, yep. Joseph's like, oh, come on, mommy. Alright. So, yep. Shay, is there a reason we're on our laptop? Alright, so if you look at these and you guys are able to identify them, it looks like, if I could do this right with my life, there we go. This coordinate point here, when you write coordinate points on a graph, it's 2 points like this. Now, on our graphs, we have an x-axis and a y-axis. And this is pretty easy. This is what I was showing the people yesterday. X, I'm going to draw it over here. Here's our graph. X is the bottom axis. If you ever need to try to remember why, it's because this whole graph, I always pretend there's all this data all over this graph, and they have a trend line, and all this information. It's heavy. So X has to put out his hands, and the X is holding it up. But you'd be like, wait a minute, Y has 2 hands. But yeah, when you hold something real heavy, you want to stand on 1 foot, or would you get big and hold it with 2? You would hold it with 2. John, if you're just going to be totally silly, I'm going to have you go somewhere else. That's a second smart aleck comment you're making. You're not being productive. So, X will get his feet, and he holds his hands up. Y is over here, and it's kind of like, here's the information, and it slides down. Okay? So, X and Y axis. That's how you can remember them. The one, let's see, Zoe told us yesterday, her teacher always taught her the phrase, Y to the sky, so Y goes up. That's totally fine. Remember, make things fun, make ways that you remember them. That's just how I always remember them. And to be honest, even though I'm a teacher, whenever I second guess myself, I was like, oh, yeah, X has to hold it. It's kind of fun. Now, when we look at this graph, you always write your coordinate points as X first, then Y. We always do this. You'll do this a lot in 7th grade and a super lot in 8th grade when you get to your algebra. So, X, Y is our coordinates. It always goes that way. We have to do it the same. That way, every person in math, we identify the same points. So, hey, oh, he's checking on you. You in trouble? How are you?
I'm here to say thank you to you.
Oh, well, thank you very much. I appreciate it.
See ya.
See ya. Bye. See, and you were just saying bad things about your dad, Grace. You're lucky he wasn't in the room. Alright, you knew that was Grace's dad, right?
Yeah.
Okay. Alright, so X and Y. In algebra, we're always going to work off that way. So, we identified the point. We went 5 over, 2 up. This coordinate point, we went 10 over, 4 up. This one, we went 15 over and 6 up. Now, can I share something secret with you guys?
Yeah.
Let's see if you guys can figure this out. Big, big, big secret here. Looking at this. So, when we looked at our coordinate points, there's 1, There's 2, there's 3. These coordinate points made up the ratio 5, 2, 10, 4, 15, 6, and they're all equivalent, right? Meaning they all equal the same. But it's each one divided by 2, I'd get 5, 2. Divided by 3, 5, 2. So they're all equivalent. How many, just right here, I know this is a line and it goes on forever, but just on this picture we have here, if I put a point on and I knew the coordinates, if I could put any point on and identify the coordinates, how many equivalent fractions do you think we could find just on what's up there?
It will vary because it's
Just off here, how many equivalent ratios do you think you could identify? Let's do it this way. I'm going to try something tricky I didn't do yesterday. How about this? I'm going to give a marker, and let's use, I didn't use orange. Let's use orange. Can anyone come up and show me where another equivalent ratio could be? You don't have to tell me what it is, just where would it be?
Wait, of
You
that
know one,
number?
Shay?
No.
Oh, then just no.
Wait, of that number?
Not yet. Anyone else? Can anyone show me where another equivalent ratio is?
Oh, yeah.
Joseph? Shay? You're still talking about focus on what we're. Simplified. Alright, that point would be 1. It looks like that's at, what, 2.5, 1?
Yeah.
That could be 1. Tristan, you think you can get 1?
Wouldn't one be right here? Because everything
Oh.
starts at...
Where? At 0, 0?
Yeah, because everything starts out at 0. It has to start out from 0.
Is 0, 0 equivalent to 5 over 2?
No.
So then no.
Wait, then how is 2 halves? Oh.
But I like your thought. It's a good conversation starter. So that one, let's get Tristan's failure off here.
Oh. Wait, I know another one then.
Okay.
I'm pretty sure.
Pretty sure you're going to miss this one.
I'm sure he is too.
That one would work. To be honest, every one of you should be able to come up and mark one. That would be one. Anna, Grace, Joseph, smart and ugly one.
Oh.
No, smart and ugly one's the same one. Smart and good looking one. Come on up.
Joseph, smart.
Find another one.
Joseph, smart and
Hurry. I'm going to give us about 10 more seconds.
Go. Just start marking. Everybody's marked.
That is one.
Joseph, just mark.
That is one.
Form a line.
That is one.
0.5.
That is one. That's one. That's one. Sort of. That's one. That's not one.
Wait, that's 0.5. That's in between 1 and 2, right?
I don't know, you're marked right here. That's not one.
Or here on the number line would be 1,
Oh,
right?
you're not on the line. Oh, on the line. That's one.
No.
Do you know how many more there are?
Quite a bit.
Infinity.
Because you just keep marking away.
This is one. That's one. That's one. This is one. One.
You just drew a line. Yeah, just draw a line.
Who said, what if I draw a line?
Yeah.
We did draw a line. What does the line represent? The line represents equivalent fractions. If you stop anywhere on the line and you identify what the coordinate points are, even if they're a decimal. Like if we use decimals again in that graph, and I can find out what this exact point is, and it's like 10.7144321, and it matches up with 4 point something, that is an equivalent ratio. Anywhere on the line, if I could identify it, it is an equivalent ratio. That is why we draw the line. The line represents every equivalent ratio. So, if our original ratio is 5:2, would 12:5 be equivalent? I'm not even going to simplify. Is 12:5 equivalent to 5/2?
Yeah. No, we can divide it in fractions and decimals.
Well, where's 12:5 going to be located?
12.
Over 12, up 5. It's right here. Is it equivalent? Is it on the line? No. The line's underneath it. It's right here. What if I gave you the fraction 9/4? Is it equivalent? Well, we go over. Here's 9. There's 4. Is it on the line? It's not equivalent. Can anyone tell me another ratio that is not equivalent? Let's do 3. Any ratio that's not equivalent that we can prove according to this graph. Caleb? 4? 4. So 4. Yeah, that's not equivalent. It is not on the line. Trevor? 0, 0. Now 0, 0 is a special one. Because it's a starting point. However, 0, 0 is not considered on the line. It's the starting point. This line is a ray. If it would have continued through, we would have to talk about, but 0, 0 is special because it equals 0. So no, it is not. Tristan.
16. There should be
16 to what?
16 to 7. Because there should be 7.
There's a 7 there. Is it on the line?
Nope.
It is not equivalent. Alright. Sure.
3.
So if we look at 3 over, 3 up, is it on the line?
Nope.
So it is not equivalent. Questions? Good, because we're going to keep rolling. Go ahead, close your notebook, and let's get our notes out of front of us. First thing we should always be doing, I want to get through our notes quickly. Today's the 15th. We are on lesson 3, 4, and 4th block purple. Alright, so, or, I don't, wow. Okay, 1, it's a silver day. 2, it's the first block of the day. Then I'm ready for the weekend. 4 o'clock, I just want to go home. Alright, so,
You didn't even get the day right, so.
I got the date right, it's the 15th.
You didn't get the day right. It would be the 16th or the 14th.
Oh, you mean if it was purple? I know. Alright,
So, you should
so let's go ahead and look at this. It says, graphing ratio relationships. I will represent ratio relationships in a coordinate point. The way we are going to be successful today are 3 things, and these are pretty simple. 1, we are going to create and plot ordered pairs from a ratio relationship. We just did that. We just identified, if I give you the ratio 3, 2, that means the ordered pair 3, 2. We're going to create graphs to solve the ratio problem. So when we draw it, we're going to use that line like we just did to identify what a ratio is. And then we're going to compare. You remember how in 3-3 we did the frosting. We did the red frosting and the red frosting, and we compared with two ratio tables. Instead of that, today you're going to see how if we do two graphs, we do one graph, two lines, how you can visually see it. It makes it a lot easier. All right. We're going to do the warm-up fairly quick because you guys did really well and we had good discussions on exploration, so I want to keep going quick. But it says, follow instructions. Label the x-axis. Okay, on a table like this that we have right here, go ahead and write this in your notes. The top one is always your x and the bottom one's always your y. You should get used to that. In algebra, we do that a lot. You'll use tables all the time. Your first term is your first ordered pair. So, it's time. So I'm going to say time. We always start at 0. And this tells me I have to go 0 through 10. I'm going to count by ones. What I'm going to do is my scale, that means that's 1. So every line's worth 1. But I'm going to skip a line. I'm going to go 1, write down 2, 3, write down 4, 5, 6, 7, 8, 9, 10, 11, 12. The reason for that is sometimes you got to read your graph. If I would have wrote every number on there, it would have been okay. However, I get a bunch of numbers and it could be kind of clustered because my graph's small. So you want to make it easy to read. That's the main point of a graph. Our y-axis is earnings. You always should label. And I need to go by 5s. So I'm going to say 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I know I'm plenty in, but that's okay. Alright. What I'd like you to do today is make sure when you have a table, you have to write out the coordinate points. So, what is one of my first coordinate points I could write down? What is my first one, Caleb? 1 to 10. X to Y. So I'm going to go over 1, up 10, mark it. What's my second one? Joseph? What? 2 to 20. 2, 20. Over 2, up 20. And then that makes my third one, obviously, 3 to 30. Alright, over 3, 30. Now, once I have this, I need to do the best job I can to make a straight line. Now, I will tell you, yeah, whoever said ruler, you're absolutely right. Whoops. Hey, what's going on here? Why can't I choose what I want? Yes. All right. Alright, now, in algebra, we make sure you guys are really accurate. You have to use a ruler. For today, I'm not going to require it, but you should start getting used to making a straight line. Now, how many coordinate points did I list?
3.
Okay, for today, please guys, every time get used to making 3. Even if it doesn't make you, you should always do 3. Does anyone know why 3, not 2?
Because I do 3 because it shows the graph better and you can learn how to go further. And with a table, if you do it on a table, it's not just 2 things marking it out, and you have to follow the same pattern.
Kinda. If I make 2 points, I can make a line, right? It only takes 2 points to make a straight line. 1 here, 1 here. Whoops. Right through those 2. Right? However, if I'm going for accuracy, 2 points don't prove that I did it right. I do a lot of building stuff. Like I made cornhole games, I like to build shells, I like to fix things. I've built different things. And when I cut the wood, I have to make sure I'm measuring the same distance. Even when I did that green football field over there, I had to cut the paper the right size, and I just ripped the big piece off. I measured from the edge. Each one of those football lines that we made, I had to draw them and measure them, make sure they're equal distance. Well, if I measured twice, I'd go 1, and let's say I measured off on this one. Now, visually, you guys can tell they're not the same, right? But could I put a ruler on here and make them a straight line? Yeah. But if I use 3 points, well, here, I'm going to keep that one off. And I did a third one, can I make a straight line out of that? No, so then I go, wait a minute. I can't do a straight line. And I've had this happen to me multiple times. I've done this, and I measure, I went to make my line, I'm like, whoa, that other point's off. Oh, I accidentally measured to a ½ inch instead of a ¼ inch. Or, if we're doing our ratio table, you multiplied and you did 4 times 3 is 16 instead of 12. If we do 3 points, it will help you make sure all your points are aligned and that you have your answers correct. Alright? So, if I asked you for what would be the next point right here? If I had 4, what do you think would come next? Avery? 45? Okay, thank you. So, Avery said 45. So I put 45 in, and now I'm going to graph it. So I go over 4, I go up to there's 40 and 45. Wait a minute, is 45 on the line?
No!
Oh, let's look at this. Avery, we're adding by a ratio, 3 plus 1 is 4. Then we do our earnings plus 10, 10, 20, 30, 40. Man, okay. So now I notice that Avery made a mistake, and the answer should have been 40. And 40 is on our line. Oh, there we go. Now I'm right. You see how using 3 points makes a line that we can check. All right. Good job, Avery. Pretty proud of you. All right. Example 1. All right. We're going to open up our laptops here in a second. Let's get through example 1, and then I'm going to get it started. It says, example 1, graphing ratio relationships. For a ratio of 2 quantities, you can use equivalent ratios to create ordered pairs of the form. First quantity to second quantity. Look in your notes. A is done for you. I want you to do B as we watch it in the video. Is everyone okay with that? Okay, so make sure you're paying close attention to it. I'm on example 3, not example 1. I'm 0 for like 3 today. All right.
Represent each ratio relationship using a graph. Part A. Use the equivalent ratios 4 to 2, 8 to 4, and 12 to 6 to create ordered pairs. The ordered pairs, flour, water, are 4, 2, 8, 4, and 12, 6. To graph the ratio relationship, start by plotting the ordered pairs. Remember, when plotting an ordered pair...
Now, you see how she got her ordered pairs of 4, 2? It's 4, 2. Remember, top is X, bottom is Y. So 4 to 2, 8 to 4, 12 to 6. We put those on there, 3 points, and we create our line. Any questions on that? You sure? Alright, so let's pause. Can anyone tell me what are my 3, remember we're using 3, what are my 3 ordered pairs then for B? This time is 1, 2, 3. Earnings was 10, 20, 30. Shar? 1 to 10. X, Y. 1, 10. 2, 20. over 2 up 20. Grace. 3 and what? 30? 3. 30. And we draw our straight line as best we can. And there's our answer. Alright. Okay, we're going to do an activity together on this. So here's what's going to happen. I will, first group gets 2, and then anyone finishing after that gets 1. Your group needs to get to Big Ideas dashboard. Go. I'll give him sugar in the morning. Send him social studies. Alright. Alright, so he will too. You gotta bring a cookie though. Alright. Miss Nordal, when we went to Denver the summer first school thing, I was in the house getting ready, and Jude and the boys were outside playing, and she showed up, and damn, I don't know if Jude remembers her, but she showed up and she goes, "Oh, your parents home?" I said, "Uh-huh." She goes, "I brought you cookies." "Oh, okay." So you took her inside. Hey, straight up brought him cookies. He's like, "That's the key to the house. There you go." Alright, if you guys would hit continue, please. Yours is over here on the top left. It's right by your textbook. Just hit there and stop. Don't touch anything else. And then I'll give you the flip link to where I need you to go. Hit continue, hit continue. You guys didn't do anything. You said that.
I know.
I was like, it's a total failure. Continue. Continue. Oh my God, guys, how are you making this difficult? There's one button that says continue. You're like, what do I hit? Alright. If you would go ahead, I'm going to give you the flip link now. Flip link should come up. Go ahead and click on it. And what you need to do is hit start. There's 2 questions and then a thumbs up. This is exactly what's on your notes, okay? You may use your notes to help you right here because here's the try it. Here's the 2 tables. Instead of making you do it on your notes, we're going to do it on the computer. Here's the table. On Big Ideas, I'd have to scroll back and forth. That's why it's a pain. I'd have to scroll back and down. So I need you, all you do is you click where your coordinate point will go. After you've done 2, it automatically makes the line for you. I'm asking you to make your 3rd dot to make sure that it goes on the line because it will. Watch this. If I mess up, it made my line. Does that mean my answer is right?
No.
No, and I can check it. It's going to tell me I'm wrong. Now, I do believe Big Ideas, for some reason, even if you make 3 dots, when you hit check, it gets rid of your 3rd one. That's okay. As long as you already did 3 and you made sure. Do question 1, go to question 2, and then do the thumbs up, sideways, or down for me. I'll do the formative check here to see where you guys are at. Wow, a lot of you are already rolling on this. Fernando's like, done.
Wait,
It's probably because he talks so much, Fernando.
Yeah.
Just a chatterbox in classes.
Wait, huh? You can't do the second one.
But,
I just beat the system.
well, I would say Zeta, Grace, Maya, Fernando, Anna all disagree with that comment about you can't do the second one.
I can do it.
Alright, continue to look at it and see if you can do it. What's up, man? What did you do, Siri?
There! What?
What's up, buddy? Oh, you're there too.
You could save.
No, it automatically does it. Oh, if there is a save, hit it.
Wait, what?
Alright. Shh. We're getting close to being done. I need to finish in about 15 minutes so we can do this. Yes, sir.
Wait, I'm actually gonna.
Are you doing what you're supposed to do? See that?
Yeah, I'm bored.
Thanks, Allie. Going series there, Jeff just got there. Size. Slacking on the job. We should have remoted in. Alright, a couple of you finish up. While the people that have just got there because the link they messed up or whatever, I'm going to move on with everyone else. So you finish those and then follow with us. Everyone go to your notes. Example 2. Okay? Oh, this is where my fun part's going to come in. Then I know that you're not going to mess around. Oh. Alright, shh. Look at your notes. Follow along with example 2.
You find dark chocolate cashews for $12.50 per pound. Part A. Represent the
Shay,
ratio relationship
last warning
using
for
a
you,
graph.
bud.
Start by creating a ratio table. Relationships involving cost are often graphed with cost on the vertical axis. So create a ratio table using the ratio of pounds of cashews to cost. The cost is $12.50 per pound. So 1 pound of cashews costs $12.50. Use repeated addition with the ratio 1 to 12 and 5/10 to create the table. Add 1 to 1 to get 2, and 12 and 5/10 to 12 and 5/10 to get 25. Use repeated addition again with the quantities from the original ratio to get the equivalent ratio 3 to 37 and 5/10. Use the equivalent ratios 1 to 12 and 5/10, 2 to 25, and 3 to 37 and 5/10 to create ordered pairs. The ordered pairs.
Alright, so mainly, here's the first thing. We were going to do a lot of this on, I don't know if I told you now, on lesson 3.5. I think I forgot to tell you guys at the very beginning. Our schedule. Today's 3.4. Today's Friday, so I'll see you again on Tuesday. On Tuesday, we're going to review. You have to have your notebooks, because we're going to put in a couple cheat sheets for you. We'll do our stations, and you'll work on your study guide. Then on Thursday of next week for you is when we'll take the quiz. The quiz will be over lessons 1, 2, 3, and 4. Okay? After that, the following week, we'll start lesson 3.5, and that has to do a lot with this. What this is saying is, I had to get the backup one. Dark chocolates are $12.50 per pound. Now, this is going to be fun. Come on, computer. Oh. There we go. Now, it's kind of cool. I can control your computer. So, 12.50 per pound. Get used to the word per. That's telling you we're doing a ratio. We're comparing. We're saying for this many pounds, it's this cost. We see this at the store all the time. And actually, we're going to do a cool activity with it in the next lesson. So when I do this ratio per pound, they put pounds first. Since it's per pound, that's 1. So it would be 1 to 12.5. If I added 1, I add 12.5. If it would have said 12.5 per 5 pounds, our ratio would have been 5 to 12.5. Alright? Okay. Looking at your notes, the question then, on example 2, after they did all the drawing for you, B, it says, how much would 2.5 pounds cost? Well, it's going to cost, but I want you to look, can anyone show me where the answer would be? Right here. Where would my answer be? I don't need what the answer is right now. But if it said 2.5 pounds of cashews, where would that answer be? Avery? Trying to do a little redemption since you said 45 before.
This is the 2, this is the 2, 2.5.
Good. So where would the cost be at then?
So the dot has to be on the line, right?
Absolutely.
So if you run that to the line, it'd be here at the
Well, very good. So everything except for that last little sentence is perfect. And I'm going to point out why. Okay? Her explanation was awesome. She said, here's 2, here's 3, so this is 2.5. Okay, the matching ordered pair, the cost, has to be on the line. So she went up, and when she drew her dot, we drew it really big and said, okay, so it's at 30. Remember, precision, especially when we get 8 here, we had a cool activity to make things really, really accurate. Has to be precise. We can't get away with, in elementary, we used to, and I do this sometimes, it's like, there's my dot. Well, look how much space that took.
That can be anywhere.
Now, in elementary it was okay because we would go by whole numbers. We're starting to work with decimals now. Because of that, your dot, if you didn't know, because we probably never taught you, a dot is actually the center point of the dot is the most accurate. So, if I said, here's the line, it's that center point. Now, is that on $30? No, there's $30 right there. We're actually just above $30. Is it going to be $35? No. Halfway between 30 and 35 is $32.50. Are we even at halfway? No, that's about halfway. We're about halfway of halfway.
$31.
Yeah, we're probably at $31. That's my estimate. Now, could we find the real answer?
Yeah.
Yeah, there's a way we find the real answer. One, we could use a double number line, what they're going to show you. Or two, listen, we did this last time. And let's see if we can finish playing the video.
So the cost is halfway between $25 and $37.50.
So,
So
just like Avery said, because I went halfway between 2 and 3, okay, so 2 is at $25, 3 is at $37.5, so I go halfway between 25 and $37.50. Half between 25 and $37.50 is $31.25. Our estimate was only 25 cents off. Okay, that's pretty impressive. Alright, we are going to skip the try it. Last one, why do I put the self-assessment skills on here?
So you can try it if you want to.
Good. Try if you want to, or if you're studying for your test, you can get your notes out to review for that lesson. Okay, last one that we're going to do, and then we'll be done. Which is, we're right on time. You guys are going to have about 20 minutes of work time today. Alright. Example 3, modeling real life. I want to ask you this question real quick. On here, I'll read it, and then we'll start playing the video, and you'll follow the notes. But I want to get you guys' idea when we start. This is just like the frosting one. You remember we did the frosting, we compared ratios? Well, this one says a hot air balloon does 9 meters every 3 seconds. So, hot air balloon, in 3 seconds, put this in your notes, we're going to go up 9. The blimp, 7 meters every 2 seconds. Now, you remember last time we created both those graphs, and then we had to compare. We said, hey, we had the same amount of red drops, who had less blue drops? We had the same amount of blue drops, who had more red drops? We had the same amount of drops, who had... Remember doing that? To be honest, a couple of classes did really well with that, and a few of them were really confused on how to do that comparison. It just didn't work right in their head. And that's okay. If that becomes tricky, what we're going to do is we're going to show you how you can graph it and make an easy assessment. Before I do, I got to get a feeling where you guys are at. So, here's my question for you. I wonder if I could do it on here. Oh, I wonder. Ooh, let's try this. Just because I want to do something. It makes me feel good about my life. Multiple choice. I don't know how to set this up. Let's see. This works. Ask a question. Let's see. I'm going to say balloon or blimp. Great. Blue. Blue. Alright, I'm gonna see if this sends it to you. Oop. I know. I'm just saying which. I'm really not writing this. I'm doing as fast as I can to see if I can use this in the future. Did it come up?
Something popped up on my screen.
Yeah.
I think you have to unblock.
Do I have to unblock you?
Yeah.
Alright. Let me unblock you.
Yeah.
Oh,
There you go.
yeah.
Alright, did the question come up for you?
Yeah.
Alright. Yep. So, A balloon or B blimp? Ooh, I see 2 people have answered. 3 people. 4 people. 5. 7. This is so exciting. It's like my birthday. Wait a minute. Where's the other 13 people? Okay. 1.
Yeah, what question?
It should be up on your screen.
It's just a big.
Yep. A balloon, B blimp.
Oh, I pressed.
Which one do you think rises faster? The balloon or the blimp?
Wait, which one was it?
A is balloon, B is blimp. Nope. Okay, 5 more seconds. 5, 4, 3, 2, 1. Oh my gosh. We're at 9 and 9. One person. Who did this? I can look it up. Andrew, I'm gonna drop kick you. He chose C.
There was no C.
A balloon, B blimp. Andrew goes C. Do you see how I'm starting to get gray in my beard? There's a reason, Andrew. Oh my gosh. He's like,
Oh yeah, I remember you saying something
oh
about
my gosh.
Andrew. That's not a misbook either.
Okay,
That's a
so watch the video, fill it out. Let's see who's right. I'm going to play the video. I'll land there, turbo.
A hot air balloon rises 9 meters every 3 seconds. A blimp rises 7 meters every 2 seconds. Graph each ratio relationship in the same coordinate plane. Which rises faster? Create ratio tables for each rising object. Then plot the ordered pairs, time, height from the table and use the graph to determine which rises faster. Start by creating a ratio table for the balloon. Balloon rises 9 meters every 3 seconds. So the ratio of time to height is 3 to 9. Add the quantities from the original ratio to produce an equivalent ratio, 6 to 18. Do this again to get an equivalent ratio of 9 to 27.
Okay, everyone get how we did that?
Now create a
Every
ratio
3
table for
seconds
blimp.
is not.
Blimp rises 7 meters every
Lady,
2
I'm
seconds.
talking. Every 3 seconds we go 9. So 6 seconds we add another 9. Another 3 seconds we add 9. Here, 2 seconds, 7. 2 more, another 7. 2 more, another 7. You should have this fit on your notes, because remember when I do your effort grade on Thursday, I'm going to look for that. Now, I'm going to end up pausing this short. We look at our table. 3 to 9 makes my coordinate points, 3 to 9. 6 to 18 makes 6 to 18. 9 to 27 makes 9 to 27. Real quick, what are my coordinate points for a blimp? Quickly. 1 is
2 to 7.
2 to 7.
4 to 14.
4 to 14.
6 to 21.
6 to 21. So we're going to graph those. Go ahead, if you can work ahead of me, do it. Graph all those points. Why should I use 2 colors?
So you can tell the difference of the line.
Yeah, if you had a colored pencil, I would do balloon, like they're going to do in red, and they're going to do blimp in blue. Can anyone be a big problem solver? What if I just have a pencil? How in the world... Hold on, I want to watch this, make sure I pause at the right time. Every other time I give away the answer. There, pause. Okay, what if I only have a pencil? How is it possible for me to show 2 different lines with the same color pencil?
Oh, you make one, like, one is normal and then label that one.
Okay, so one's normal and then one I shaded darker. You can do that.
One's like dashed and one's straight.
Good. Always problem solve. You want to be able to visually see this. Alright, now we have this picture of this graph. I'm not going to give the answer yet. I'm going to re-ask the question for you. This time, Andrew, how about we not put C? You know, I mean, just maybe. All right. I'm going to try sending it again. All right. Do this right, because I might give something to the people that get it correct. Okay. Which one is rising faster now that we visually see this? Is it the blimp or the balloon? I'm going to shut it down in about 5 seconds. 5, 4, 3, 2, 1. Alright, so unfortunately I had 6 people that got this incorrect. The correct answer is the blimp. Now, pay attention. Why? They're both here. Here's height going up. The blue line is on top of the red one. It's higher up. It gets to a point before. Remember, time's how long it takes. So the blue line's going higher, faster than the red line. If we were to do it like we did in 3-3, look at our 6 seconds. In 6 seconds, the balloon went up 18 meters. For the blimp, in 6 seconds, we went up
21.
That's how else we can compare. All right. What?
Also, if the blimp went 3 seconds, it'd be 10. It'd be going 10.5 meters a second.
It's a good way of using number sets. All right. Last thing. Here we go. I'm going to tell you on your homework what you're doing. 1. If you have not finished Desmos, you have 20 minutes left of class. You need to start working on it to get it done and turn it in today. 2, if you're working on homework, pay attention to this. You must show work. Now, the very first one, the table's there. I want to see on your paper. You write number 1. You may abbreviate on your table if you want. FS. But you had 6 to 2. You had 3. Get a blank. 15. Okay. I need to see on your paper, how did I go from 6 to 3? I divided 2. So 2 divided by 2 is 1. How did I get from 1 to 4? I times 4. So I did 3 times 4. Okay? Now, everyone needs to be up here looking. I already blocked your computers. You can't be doing anything else. Okay? You get how you have to show that work. That's one question you have to show work on. Number 2. This is your graph. It says 45 miles per hour. There's no table. I hope you're listening, because if you mess this up, you're going to miss it. You should say, okay, time is here. Distance is there. Remember, X to Y. If it went 45 miles in 1 hour, there's your first ratio. How many ratios do you have to have?
3.
Okay, even if Big Ideas is not making you, when you turn this in, I'm looking at everyone's paper to see, did you make a table with 3? Okay, so number 2, if there's not a table, you have to show it. That's 2 questions you have to show work on. Number 3, is there a table?
No.
You must show work. That's 3 questions. Number 4, hey, there's a table. So do you have to show me any work?
Yeah.
Nope. You just have to graph it.
Oh.
Number 4, hey, there's a table. Do you have to show any work?
No.
You have to graph it. Oh, number 6, there's a table. Do you have to do any work?
Nope.
Show me you know how to graph it. Hey, number 7, there's a table. Do you have to show any work?
No.
Graph it. Hey, number 8, there's a table. Do you have to show any work?
No.
Graph it. Hey, number 9, there's a table.
No.
Hey, number 10. Oh, is there a table?
No, but I know what it is.
So do I have to show my work?
Yes.
4 questions you must show work on today. Unless you get lesson A. If you get homework A, you get something different. Ha
How you search?
That's tough.
Alright, all block your computers. Let's get to work. I'll be around to help you.
What if we need